So we will do one by one. If any problem, then tell me. These are related to what? Real number. Chapter name is what? Real number. That's one so much importance. So here given property related to LCM, HCF. So saying the sum of LCM and HCF two number is this. Two number given, their LCM and HCF sum is this 1260, and their LCM is what? 900 more than their HCF. LCM is 900 more than their HCF. Then the product of two number is, so you can start like this. Let the HCF of two numbers, what's X? What's X? Therefore, LCM of two numbers, LCM is 900 more than its HCF, so how much? 900 plus X. Now, according to the questions, sum of HCF plus LCM is equal to how much? 1260. So HCF how much? X, and this is how much? 900 plus X is equal to 1. How much? 2X plus 900 is equal to 1260. If we can solve it, so 2X is equal to 1260 minus 900. So 2X is equal to 360, X is equal to 180. X is 180. So HCF equal to 180. LCM is equal to what? 900 plus 180. So 1080. And what's the product? It's meaning 1080 into 180. Understood? So you can multiply 1080, 180. So 1, 2, 3, 4, 80, 64, 8 into 0, 8, 0, 1. So 0, 0, 2, 0, 0, 2, 8 plus 4, 2, 8, 0, 0, 0, 0, 0, 8, 0, 0, it's 8, 8, the 64, 6, 8, 8, as it is this, 1080. So how much? 12, 7, 9. So what's their product? Product is given this. So once more we will check what problem is there. So this is given. So their HCF is this, LCM is this. So sum of these LCM and HCF two number is this. HCF plus LCM is equal to this. So this is 2X, 900 coming 300, 180. This is 1080. 1080 into 180. So 0, 0, 0, 0. 800, 8 6 are 40, 64, and this is what? 8, and what? 0, 8, 0, 1. This in this will become wrong. 0, 0, 4, 4, 9, 1. 194 anywhere, 400. So what's your answer? This is your answer. This problem in this calculation. So understood? So, what's its answer? Got? Next, the ratio of LCM and HCF of the list composite number and list prime number is. List composite number. So 1, 2, 3, 4. So which one is the list prime number? 2. 2. And list composite number 4. Composite number meaning having more than 2 factors. So 1 only 1 factor, 2 only 2 factor, 1 and 2, 3 2 factor, 1 and 3, 4 3 factor, 1, 2 and 4 itself. So 4 is a composite number and 2 is a even prime number. So the ratio of the LCM and HCF. So first find out their HCF. Their HCF equal to 2. And what's their LCM? LCM equal to 4. So what's the ratio? LCM raised to HCF. 4 raised to 2. It's meaning 2 raised to 1. So which one is your answer? This. Got? Try to understand only prime factor of the denominator of a rational number with decimal. So this is given. Try to understand. Very important questions. Not anybody telling to you. So what type of number this? Terminating or not terminating? It's a terminating. After decimal 3 digits are there. So definitely it is a terminating. So if terminating, so factor of denominator in the form 2 power n, 5 power m. Here n and m are whole number. What? Whole number. It's meaning denominator factor either contain 2 or contain 5 or contain both. So what C is its answer? Example you can take, if this you have taken 13 by 7. So terminating or non-terminating? Directly I can say this is non-terminating. 13 by 5 terminating. 13 by 10, 13 by 2 into 5 terminating. 106,543 divided by 15. First convert this into simplest form. So what's 16543? It's not divisible by 3. It's not divisible by 5. Not divisible by 3. Why? Some of these 4, 7, 12, 18, 19. So not divisible by 5. If unit digit is 0 or 5, then divisible by 5. So this contained, it's saying directly we can say non-terminating. If denominator factor are 2, only 5, or both 2 and 5, then terminating, otherwise non-terminating. Understood? This given if a square is equal to 23 by 25, then a equal to under the root 23 by 25. This we can write under root 23, under root 25. And this we can write under root 23 by plus minus 5. So terminating or not, it's meaning this is a irrational number and this is a rational number. Irrational divided by rational is always irrational. What's always irrational? So what's your answer? P. Got? Next. All are busy. LCM of this is 36. HCF 2. So we know first number into second number is equal to their LCM into HCF. So what's given? It's given 36 and 2 is their LCM and number is what? X into 18. So X is equal to 36 into 2 by 18. 2 is how much? 4. So X is equal to 4. Anywhere? Yes. What's the benefit of these multiple choice question? So benefit of these multiple choice question is this: you can understand this chapter very well. if you can solve the multiple choice question related to that chapter. If the sum of two number is this, 1215, and their HCF is 81, then the possible number of pair of such numbers you have to find out. So their HCF is 81. So HCF is always a factor of given number. So we can select two numbers are X and Y. So according to the question, 80Q, 81X plus 81Y is equal to 1215. So 81 taken common, X plus Y 1215. So X plus Y, how much? 1215 divided by 81. 9 ja, 9 1 ja, 3 ja, 5 ja, 9 1 ja, 5 ja. So what's X plus Y is equal to 15. So possible pair 0 15, 1 15, 14, sorry, 2 13, 3 12, 4 11, 5 10, 6 9, 7 8, 8 7. So this and this same. After this start repetition. But this is not possible. But this is not possible. If this 0, then this becomes 0. So their HCF not 81 possible. Understood? So leave this. So how many? 1, 2, 3, 4, 5, 6 and 7. So next 8, 7, 9, 6, 10, 5, 11, 4, 12, 3, 13, 2, 14, 1. So these repetition. So how much? 1, 2, 3, 4, 5, 6, 7. These cancel. 8, 7, 7, 8. Both are same. 9, 6, 6, 9. 10, 5, 5, 10. One we can take. 11, 4, 4, 11. 12, 3, 3, 12. 13, 2, 2, 13. 14, 1, 1, 14. So count this. 1, 2, 3, 4, 5, 6, 7. So what's your answer? C is your answer. Got it? So if you can understand each and everything. If LCM of two prime numbers P and Q is this, then the value of 3P minus Q is equal to what? Understood? LCM of two prime number. LCM of two prime number. Prime number meaning nothing common between them. P and Q are co-prime. So what's their LCM? LCM is meaning P into Q is equal to 221. So what's your P? P is equal to 221 by Q. So put here this 3 into 221 by Q minus Q equal to 0. So what's it's become? 663 minus Q square equal to 0. So 663 equal to Q square. So Q is equal to 663 under the root. So find out 663, factor this. 2 2 ja 4, 2 plus 2 4, 263. What's it's become? 63. So what's it's become? and P is greater than Q. P is greater than Q. This we have to find out. This we have to find out what's the value of 3P minus Q. So what's its become? 3 3 ja 9, 4 5 ja 6, 6 ja 7, 8 8 ja 9 9 ja not possible. So another method we can apply. So what's saying? The product, if the LCM of two prime number is equal to LCM, meaning if prime number, it's meaning nothing is common between them. So what's their LCM? LCM is equal to P into Q is equal to 221. Understood? And what we have to find out? We have to find out 3P minus Q. What we have to find out? 3P minus Q is equal to what? Is equal to what? So you can find out this. Understood? This is equal to this. So what we can do? You can write prime factor, its factor you can make. 221. This is divisible by 2, not divisible by 3, not divisible by 4, not 5, not 6. If not 2, 3, then 6. 7, not 7 what? Not 8, not 9, not 10, not 11. 11 is this 2 plus 1, 3, minus 2, not divisible by 12. If not divisible by 3 and 4, not 13. Check one time. So 221, 13, 13 ones are 13, no, 17. So this we can write 13 into 17 is equal to 221. But P is greater than Q, therefore P equal to 17 and Q equal to 13. Put here value 3 into 17 minus this. So 51 minus 13 is equal to 38 is your answer. What's answer? 38. Understood? All of you, just this you have to understand in this question. Which one is the key point here? Two prime number. So prime number, you know, having common what's? Only one is common between them. 3 4 3 5 3 7. So like this, two prime number. So and their product is equal to this. So we have taken this equal to this product, and if we can divide this, so these are prime, so we can divide them. P equal to 17. Why? P is greater than Q given, that's why. So this is how many prime number are of the form? Which form? This form. 10n plus 1. And look one time this. What's the value of n? N is either equal to 1 or less than 10. Less than 10. And what is n? N is a natural number. Natural number, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 not included in it because it's given less than. So put one by one value. So this is coming 11, 21, 31, 51, 41 also, 61, 71, 81, 91. We can put 1, 10 plus 1, 11, 2, 20 plus 1, 3, 30 plus 1, 4, 40 plus 1, 5, 50 plus 1, 6, 60 plus 1, 7, 70 plus 1, 8, 80 plus 1, 9, 90 plus 1, 10, 10 not possible because here this is not equal to this given. If this given, then we can take also, and n is natural number. So possible value are these. How many of them prime? 11 is a prime number. What's 11 is a prime number. 21 divisible by 3 and so on, not a prime number. 31 prime number. 51 divisible by 3, not a prime number. 41 prime number. 61 prime number. 71 prime number. 81 not divisible by 3. Divisible by 9, divisible by 27. 91 divisible by 7, divisible by 13. So this also not a prime. So how many? 1, 2, 3, 4, 5. Is there answer 5? Yes. So this is the answer of it. Got? Look now. Any one of the numbers, this a plus 2 and a plus 4 is a multiple of this. Any one of the numbers a plus 2, a plus 4 is a multiple of what? So what is a? A is not defined here. So a is not defined here. So what you can write here? What you can write here? So this I can tell you. Statement I am checking. So about a is not given anything. Saying if a given in this any one of the number a given integer. What's given? Integer. So look one time. It's given any one of the numbers. This is a multiple of, and then coming here, a is any integer. A is any integer. A is not defined here. That's why I have told this. I am taking like this. If a equal to 1, what is this? 1, 3, 5. Understood? If a equal to 2 taking, so 2, 4, 6. A equal to 3 taking, 3, 5, 7. Look one time. Example I am taking. A equal to 4 taking. So what's become? 4, 6, 8. A equal to 5 taking, 5, 7. And what's 9? So look. Whose multiple is this? 3. In this, anyone is a multiple of 3? Yes, 6. In this, any multiple of 3? Yes. Here, look. Any multiple of 3? Yes. Here also, multiple of 3. But here, not multiple of 2. Not multiple. Your answer 2, 3, 5, 7 given. So, what's your answer? B is your answer. Not understood? Yes or no? You can take example. So, look one time. First one is not a multiple of 2, not a multiple of 7, but multiple of 3. Second, we are taking multiple of 2, multiple of 3, but not a multiple of 5 and 7. So here also multiple 3, here also multiple 3, here also multiple 3, here also multiple 3, here also multiple 3. So if this type of number given and this is given in integer, then is a multiple. Otherwise, you can take what? A equal to take minus 1. Minus 1. So what's coming? Minus 1 minus 1 plus 2, minus 1 plus 4. So what's coming? Minus 1, 1, 3. This is also a multiple of 3. Whose multiple? 3. Got it? A equal to minus 2 taken. A equal to minus 2 taking. So minus 2, 0. And this is what? Minus 2 plus 4. So minus 2, 0 and 2. Not a multiple of 3. So here coming, where A is any positive integer, this kept in your mind. 3 is your answer only when A is what? Any positive integer. I think understood. Understood? This is saying like this, if A is any positive integer, then these, any one of these is a multiple of 3. Understood? If the LCM of 18 and 36, if the LCM of A and 18, so we can write here LCM, whose A and 18 equal to 36, and HCF of A and 18 is equal to 2. This we have done. Already we have done here. Look one time. This we have done here. This. Same as it is. So next, what? Understood? This is the LCM, this is the HCF. So we know first number into second number is equal to their LCM into their HCF. So first number A, second number 18, LCM 36, HCF 2. So what's your A? 36 into 2 by 18. 18 2 ja, so A equal to 4. Already told you. Yes or no? Next. So look one time, important points. This P and Q are co-prime. Prime, you know, prime is having only two factor, one in itself. Co-prime is this, nothing is common between them, only one is common between them. So example, you can take 3, 5. So what's their HCF? 1. If the HCF of two number is 1, so we can say they are co-prime. 5, 6. What's their HCF? 1. So this is also co-prime, this also co-prime. 4, 5. Their HCF also 1. Whose HCF is 1? If the HCF of two number is 1, definitely they are co-prime. And what about their square? So this how much become? Take 9, 25. What's their HCF? This also 1. What's HCF? 25, 36. Their HCF also 1. And what's this? 16, 25. If you can find out their HCF, that's also 1. So what you can say? They are also co-prime. So what's your answer? A. Co-prime definition, two type you can say. One is this, two number, if one is common between them and other than one, nothing common, so co-prime. Other than what you can say? Second definition, what you can say? If their HCF is 1, one more definition, if the LCM is equal to the product of two number, then also two number are co-prime. So three definition I told you, you can understand. Prime, I told you. So now next one. Next one. If 3 is the least prime factor of a number, A and 7. A and 7. A is this, 7 is this. Is the least prime factor of the number, and 7 is the least prime factor of B. It's meaning two number given, one number is A, whose least prime factor is 3. So first we will find out that number. 2 not. 3 is that number. 3 whose least prime factor is what? 3. 4 not. 5 not. 6 2. So 3 is the least. 3 is that number whose least prime factor is 3. If we can take 2, 2 is also a factor of 2. So one number is 3, and B is that type of number whose least prime factor is 7. I think not understood. So what type of example we can take? 1 not, 2 not, 3 we can take. 3 is possible, 4 not possible, 5 not possible, 6 prime factor 2, 7, 3 is not a prime factor of that, 8 is not, 9 is not a prime, 10, 11, 12, 13 is a prime, 14 is a prime. So the least prime factor of a number. So 11 not, 12 to 13, 3 is not, it's 14 not. So 9 we can take. After 3 what's coming? 9. Here first one is 7, next one is what? Next one is what? 14. Is it 14? No, 14 is not, because 2 is a factor of it. 21 not. 3 is the least prime factor of it. 28 not. 35 not. 5 is given. 42 2 factor. This also not. 49 yes. So 49. So in this type of number you can find out. Then what's the sum of this and this? 3 plus 7 is equal to 10. And 9 plus 49, that's also 58. So sum of this type of number is what? Always even number. Always even number. So least prime factor of this, their sum is what? If number is even, so 2 is the least prime factor of them. What? 2. So what's your answer? 2. What's your answer? 2. Got or not? I think understood. Any other example you can take? No problem. This given the smallest number by which under root 27. So under root 27 we can write like this: 3 into 3 into 3, and this we can write 3 under root 3. We can multiply. Should we multiply so as to get a rational number? So get a rational number. So if we can multiply this with 3, this one 3, so it's become 9 under root 3. But if we can multiply this with under root 3, so this become 3 into 3. What's coming? 3 into 3. What's 9? 9 is a rational number. So which one is the least? This one. Which one? This one. This one also, if you can multiply with this, then also coming a rational number. But saying least, which word using? Smallest. That's why its answer is this. This also possible. You can write under root 27 into under root 27. So this is coming 27. 27 is a rational number. But saying smallest, so smallest is under root 3. Got? These are very simple. 3 bells ring at interval 4, 7 and 14 minutes. So in this you have to find out what you have to find out. Directly you have to find out LCM of this type of number. So 2 2 ja 7, 7, 7, 2, 1, 1, again 2, 1, 1, 1. 7 to the 14, 14 to the 21. And all the three rings at 6 a.m. So first they rang 6 a.m. Understood? When will they ring together again? After 28 minutes. So this is in 6:28 a.m. So this is your answer. What's your answer? C. So important one, easily you can understand. It's given 4 9 power 2n minus 4 power 2n is always divisible by. So how can we write this? We can write 9 power n and its whole power 2 minus 4 power n its whole power 2. Understood? This is become a square minus b square. What are its factor? A minus b, a plus b. Understood? So it's divisible by this number 9 minus 4 and 9 plus 4. So 9 minus 4, 5, 9 plus 5 and 13. So this number is divisible by this. So make a square minus b square. If not understood this, we can write 9 power n equal to a, 9 4 power n equal to b. So it's become a square minus b square. So a plus b, a minus b. Got? N is a natural number. N is a natural number. Understood? Here also hint given 9 power 2n. This is of the form a power 2n, b power 2n, which is divisible by both a minus b and a plus b. So this also divisible by this and this. Got? Next, if any natural number, then n is a natural number, then 6 power n minus 5 power n is always end with meaning unit digit. What's its unit digit? So you can check one time 6. If it's power 1, then 36. If it's power 2 and 3, this 4, then must unit digit is 6. So here also unit digit 6, 6, 6, 6. And here 5, 25, 125, 625. So it's also unit digit always 5. So what you can say? Always end with 6 minus 5 is equal to 1. So anywhere given 1? Yes, given. Hint also given. For any n belong to n, it's meaning this small n is a natural number. And what are natural number? Which start from one end with infinity. And the difference between the preceding and succeeding number is always 1. 1 or minus 1. Understood? So 5 power n, where n is a natural number, then always its unit digit is 5. And 6 power n, where n is a natural number, then definitely the unit digit of that number is 6. So how much difference? 6 minus 5. What is 1? Always end with 1. So this, if you can solve this, this definitely end with 1 in unit digit. So it's also unit digit. What coming? 1. Got? Next. Show the remainder when the square of any prime number greater than 3. So greater than 3 prime number. So 5, then 7, then 11, then 13, 17, 19, 23, 29, up to 100, total 25 prime number. Total 25 prime numbers. Understood? But I am taking these as the remainder when the square of any prime number greater than 3. Square of this is divisible by, so number greater than 3 is remainder. What's remainder coming? Directly you can take 25 divided by 6, remainder is 1. 49, remainder is 1. 11, 121, remainder is 1. So in all cases, remainder is 1. So any number which is prime and greater than 3, so of this form 6 and plus minus 1. If n equal to 1, and this is this, so it's become 7. If minus, then become 5. 2 taking, then 11. Understood? 2 taking, then 11. So 13, 3 ja. 13 meaning 2 ja, 6 ja 12 plus 1, 13. 17, 6 3 ja 18 plus minus 1, 17. So this is, so in this way we can write every prime number greater than 3 we can write in this form. Here n is a natural number. N is a natural number. Got understand this or not understood? If this understood, remaining also you can understood. So this you can write, what's the square of 6n plus minus 1 square. So this is 36 n square plus 12 n minus plus 1. Clearly I can tell if not understood this. Look one time. So we can write, if a prime number greater than 3, if a prime number is greater than 3, so every that prime number we can write of this form, either this form or this form. So taking square of it, so how much? 36 n square plus 12n plus 1. So this part is divisible by 6. So remainder how much? 1. Remainder how much? 1. This taking its square 36 n square minus 12n again plus 1. So what's common? 6 taken, n square minus 2n plus 1. So this is divisible by 6 and remainder how much? 1. So in each case, what's remainder? Remainder is 1. And what's its meaning? Its meaning is this: if anybody is saying this is a prime number, how much big is it? This is a prime number and it's divided by 6. What's your remainder? Directly you can say its remainder is 1. How much big is it? Got or not? Written here, any prime number greater than 3 is of the form this, where k is any natural number. And then if you can solve it, so coming of this form. This is the application of this question. Given one prime number greater than 3, and if you can divide that prime number by 6, so always remainder is 1. Next. For some integer m, every even integer is of this form. It's meaning for some integer. And even integer, even meaning 2, 4, 6, 8, 10, 12, minus 2, minus 4, minus 6, minus 8. So in this. And if m is any integer, so how can you write? We can write 2m, where m is any integer. M is any integer. So 1 taking 2, 2 taking 4, 3 taking 6, 4 taking 8, 5 taking 10, 6 taking 12, 7 taking 14, 8 taking 16. And if we are taking minus 1, so minus 2, minus 4, minus 3, minus 6, minus 4, minus 8, minus 5, minus 10, minus 6, minus 2. So how can we write? In this way we can write. Got? For some integer q, every odd integer, odd meaning which is not divisible by 2, even which is divisible by 2. So we are after odd integer. Odd integer q. So integer meaning 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21 continuous. Its meaning is what? Whose unit digit is what? Not 2, 4, 6, 8 or 0. Understood? So what form? What form? So we can take what we can take. If q we have taken, I am taking an example q. Q taken, q equal to 1, 1, 2, 2, 3, 3, 4, 4. But 2 and 4 are not odd integers. So this is not the answer of it. But if you can take q plus 1, q plus 1. So that's also we are taking q equal to 1. So directly coming to 2 taking 3, 3 taking 4. These are also not even integers. Oh, sorry, odd integer. These are even integers. So this is also not its answer. So this taken 2q, q equal to 1 taken 2, q equal to 2 taken 4, q equal to 3 taken what 6, q equal to 4 taken 8. All are even integer, but what we need? Odd integer we need. So last, this is q here, 9 not, this is q. So check one time, we have taken 2q plus 1. So q equal to 0 taken. If 0 we can put 1. 1 taken 3, 2 taken 5, 3 taken 7, 4 taken 9. Satisfying? Minus 1 taken, minus 1 take 2 into minus 1 plus 1. So minus 2 plus 1, which is minus 1. So minus 1 also you can say. Minus 2 taken, so 2 into minus 2 plus 1. So minus 4 plus 1, which is minus 3. So these are also integers. So directly we can say which one is its answer. D is its answer. So important, you can use these property where? These property in the competitive exam. If saying like this, what you can say? Saying this is a odd prime. So how can we write? We can write 2q plus 1 where q is any integer. Any integer meaning either positive integer, negative integer, or neither negative nor positive. Next, 46. All decimal numbers. All decimal numbers. Decimal number meaning 1.2, 1.432, 1.3564, 1.32154312 continue till infinity. Rational number? No. Some numbers which are in the form of decimal but not rational. Under root 2, what's its value? 1.41 and continue going on till infinity. So it's in the decimal form, but this is not rational. So this is not. So this is not. So which one? Real number. So decimal numbers are rational also, irrational also. So combination of irrational and irrational is what? Real number. What? Real number. Saying integer thought. Integer are that number which are complete, never in the form of decimal, never in the form of fraction, never in the form of under the root. So definitely not. So what's your answer? C is your answer. If a into 5 power n and with the digit 0 for every natural number n, then a is what? Any natural number we can check. N equal to 1 taking, so 1 into 5 power n out, so it's meaning 5 power n. We have done, if 5 power n is a natural number, so its unit digit always what? 1. Sorry, always 5. 25, 125, 625, all where unit digit is 5. So n is not natural number, not possible. N is a even number, so we will take n equal to 2 taking. N equal to, a equal to 2, sorry. Then a is a equal to 2 taken, so 2 into 5 power n, 10 power n. Definitely its unit digit is what? What's its unit digit? 0. So 4 taking, so 4, then also this coming 20 power n. Definitely unit digit 0. So what we can say? An even number. And if we can take a odd number 1, 3, 5, then it's not coming. None of these not possible. So which one is its answer? This is its answer. And next one, you know, the product of a non-zero rational number and a irrational number. Product of a rational and irrational is always irrational, but that one need non-zero. If you can zero multiplication with a irrational number, so that's equal to 0. And what is 0? 0 is a rational number. Why? 0 we can write 0 by 1. So p equal to 0, q equal to 1, and both are integer. So 0 is a rational number. That's why using word non-zero. So product of a non-zero rational number with irrational number, always irrational number. Sum of a non-zero rational, sum of rational plus irrational, always irrational. Subtraction of rational minus irrational, always irrational. And in case of division, then again coming non-zero. Understood? So what's your answer? Always irrational. So this already I told you. So what's given? 25 power 2n minus 9 power 2n. So this we can write a square minus b square, and which is equal to a minus b and a plus b. What we can write? A plus b. So how much? 25 minus 9 and 25 plus 9. So it's meaning 16, and this is 34. So this number must be divisible by both 16 and 34. Already told in previous portion of this. Understood? HCF of two positive integer is always HCF of two positive integer is always multiple of their LCM, factor of their LCM, divisible by their LCM, none of these. So this is not possible. And LCM is always greater than or equal to LCM, HCF. So, what you can say, divisible by their LCM. If LCM is greater than their HCF, so how can divisible? Not divisible. And factor meaning either equal to that number or less than that. So HCF is always less than or equal to the LCM of two number, two or more than two numbers. So this is this factor. B is your answer. Multiple meaning greater than or equal to. So LCM is what? LCM is what? Multiple. Understood? LCM is a multiple of HCF like this 4, 8, 12, 16, 20, 24. All these are multiple of what? 4. 4 into 2, 8. 4 into 3, 12. 4 into 4, 16. 4 into 5, 20. 4 into 6, 24. So, all these are multiple of 4. So, and 4 is also a multiple of 4. So, its meaning, if number is less than, so what we can say? Factor, its meaning 1, 2 and 4 are the factor of this 4. And LCM is always greater than, LCM is always greater than or equal to HCF. Equal to sign coming only when? Never equal to. Sorry for that. Equal to somewhere we can say, like this we are saying, what we are saying? 1, 2. So equal to sign also not coming, and LCM is always greater than their HCF. Understood? So what's your, it's a factor of it. And if a number is less than the given number and divide that number less than or equal to, then definitely that number is a factor of that. And it's meaning what's HCF is always less than the LCM. So definitely it is a factor of it. So this is all about today lectures. I think you understand some very important question given, so that you can revise, use that method in competitive exam, easily able to find out. And if you want to solve in the exam, not able to solve, if you can use that trick, easily able. One of them is this: what may be the number given, prime number given, but greater than 3, and you can divide that number by 6, so always remainder is 1. Another one is this type of question also. Directly you can solve in exam, applying by this A minus B, A plus B. So it's meaning sum of these and difference of these. So directly 25 plus 9, 34, 25 minus 9, 60. Need not be solving this just for telling. Understood? So I think you understood this. So we will take remaining more question also related to this chapter. So you can revise these. If anywhere problem, tell me. Thank you all of you. Best of luck.